everyone. Today I'll be covering antiderivatives and the first fundamental theorem of calculus. Antiderivatives, also called integrals, calculate the area under the graph between it and the x-axis, and is done by using the sum of the areas of rectangles of width dx and height f of x. Now, to get an exact measurement of the area under the graph, the number of rectangles used needs to approach infinity and the width of those rectangles needs to approach 0. The first fundamental theorem of calculus is where integrals also get the name antiderivatives, and to explain it, we can use this function as an example. Let's say we have a function g of x that calculates the area under the function f from a to x. Well, let's say this is our function. The area from 0 to x can be represented by this little triangle, and the area under the graph of f from 0 to x plus h can be represented by this bigger triangle. Now, this area between these two bounds is g of x plus h minus g of x, which can also be approximated by a rectangle of width h and height f of x. Now, since this looks very similar to the limit definition of the derivative, rearranging to solve for f of x and adding on a limit as h approaches 0, we can recognize that g prime of x is equal to f of x, or basically the first fundamental theorem of calculus states that derivatives and integrals undo each other. Let's do a simple example. Find g prime of x given this function. Well, by fundamental theorem of calculus, we know that g prime of x is just this function under the integral, or square root of 1 plus x squared. But it gets a bit more complicated when there's chain rule. Let's evaluate this derivative. Well, we do the same thing. We just get rid of the integral symbol and just keep the function while substituting in x to the fourth. But since there's an inner function, now we have to apply chain rule, and this is what we get. Indefinite integrals are integrals without upper and lower bounds, like we just saw. And essentially, the most important part is that when you integrate, you have to add a plus c because the derivative of any constant is 0. Let's do an example and pause the video and read the problem. Well, first thing we do is take the integral of f double prime of x, which gives us 2x plus c, or f prime of x. Then we substitute in our known values and solve for c. After that, we integrate again to get to f of x, and we solve for c again, and then we get this final expression for f of x, or x squared plus x plus 4. Thank you guys for watching.